Good day, everyone. I want to welcome you all to this case study presentations on building information model for infrastructural planning and design of road and drainage network in this virtual conference of BIM Africa. Before I start my case study presentations, I would like to introduce myself once again. I'm Engineer Abubakar Lawal, the Design and Project Manager for Infraworks Engineering Services Limited, based in Nigeria. One of the modern applications in the architectural engineering, construction, and operation industries is the application of the building information modeling to our infrastructural planning and design of road and drainage network infrastructures. These are termed as horizontal BIM applications. Now, in today's world, we have to take a critical look at our infrastructures on how we plan it and get right for all the details we want. So let's go through it. This is my link to activate one of the two critical software that we use for these presentations, which is Autodesk Civil 3D 2021, which I will launch, and at the same time, I will use Infraworks 2021 for the first update launch as well. So in order for me to start, I'll quickly give us an overview because I just have only 45 minutes to give these discussions. Now, in the approach of what we use to plan or to strategize on this infrastructural layout, we have to define what is the most important details on the site. I'm going to show us a case study, which is an extract from an ongoing project, which will decide to bring part of it out in order to use to explain these case studies. Because of the time durations, I take special considerations to focus on the BIM part of the procedure. Because for the horizontal BIM applications, we make use of the BIM and the GIS tools. But in this case study, because we are working from a virgin environment which has not yet been built up, except farmland, which needs to be converted into an estate, into a sustainable estate. So the extract you are seeing here from the screen is just a cutout from that project. Other extensions have been carried out in the project. As you see in this case study, we were able to coordinate GIS procedures and as well as using the base map applications from Infraworks through the model builder to get our images, that is the raster image. But application of BIMs warrants some challenges which we have to resolve. Now, in order to showcase what we've seen here is just a control that we're taking from drone flight in order to get the exact conditions of the topography of that environment at the time that we do the capturing. So the second software which we use is Infraworks. Let me open it because I'll be interchanging between these two interfaces, Autodesk Civil 3D and the Infraworks. So let's open the Infraworks to see how we coordinate the workflow for the planning and design of road and drainage network within the site area coordinations. Now, the Infraworks is the Infraworks 2021 updated 0.1. Then I click on it to show the coordination we've done in Infraworks. Because before we can start, based on the work that the town planner have carried out and also the surveyor have not done the detailed survey of that area, so we have to use a faster means of getting our survey data by flying a drone on the site and with a control point to get the ground control details and get exact survey data, which give us an accuracy of 0.1 plus or minus. And doing that, we should be able to extract our spot height elevation for the site condition using the point cloud conversion procedure and also using the digital elevation models and the digital terrain model integrations to Infraworks to get the exact topo of the environment. Let me quickly show us how we coordinate that in Infraworks. On the launch of InfraWorks, this is the site coordination that we did. Because of time, I don't want to digress into so many technicalities, but what we've achieved on these present work situations is what I want to showcase for us today. Fly a drone, process the data, and get a geotiff map in the coordinate system, and we'll put it exactly at the locations. That's why what we are seeing overlaying the InfraWorks model builder imageries is the raster images from the geotiff file coordinations and process data that we have updated on the InfraWorks. So that's why we are saying it. It's showing me the line of the existing condition of the site, which is mostly a virgin land, showing the stormwater tributary, because this capturing was done during the dry season. Assuming it was captured during the rainy season, definitely the InfraWorks model builder will show us the river flow line tributaries as information that will guide our design of our storm water connections. So because this capturing was done in was taken for the model builder during the dry season, and at the same time the drone flight was also carried out during the dry season. That's why you can only see the tributary line has been updated, but you cannot see water flowing, but just see the pattern of what the external water that have been shown in the map. So from here now, how do we easily coordinate our informations using this case as a case study? This is an interface. I have to work between InfraWorks and Civil 3D. Now I'll go back to Civil 3D. In Civil 3D, I can see what the town planner have done in order to provide building and infrastructure in this. But as an engineer and civil infrastructure design engineers, we have to make provisions for the road and drainage network in line with the design criteria and standards. So, and you can see, based on our coordination with getting the recent flight condition of the map of the environment, we're able to access where the river tributary is being in order to adjust the planning of the site by the town planner in order to reflect an offset from the major water river line tributary so that it should have a expandable distance in order not to affect the plot of land around that tributaries. So that's what leads to the adjustment in these procedures. That's why it's very important that when you are working with the print processes, all the things need to be carried along with the process of applying the 4 C's in terms of collaborations, coordinations, cooperations, and connectivities. So in this case, I will coordinate information. So the next thing I will do is to now extract the detailed information I need in order to build that information in InfraWorks as using the BIM tool. But I need to coordinate the reference line as stated here in order to give the desired result so that everything can be located in the InfraWorks tools that I'm going to use for this approach. The process map in geotiff file has been shown in Civil 3D. It can be imported through the map coordinate system as well as the process map from the InfraWorks interface, which was positioned with respect to the output format. So the layouts as coordinated in the 2 layouts was shown to show us how we can coordinate our design build up in InfraWorks using the BIM tools. So in order for us to continue, kindly remember that some of the process were shortened in order for us to allow us to showcase the theme of these presentations as case study, which we've done for other case study as seen here, as observed from all these coordination that we have seen. So these are information built up with a complete designs for the road and stormwater drainage as explained. So going back to the procedure to now coordinate what the town planner has conducted, I need to start to follow this pattern. I'll just select a few road design corridor for the major roads and in the estate and the other road as stated. But using InfraWorks to coordinate the procedure of designing the road and the stormwater drainage. Now, what we need to do is, from the creative design from infrared software, we consider the transportation utility that we want to use and select component road. Component road is a criteria when you want to design a road with design standard and criteria. Where planning road is when you create a default road in order for you to plan a layout as a default. So it's only when you turn it into, when you convert it to a component road, that it can specify the design criteria for that road. So in this case, I'm using directly the component road details. I can decide to use the planning details of the road, for instance, before I do a critical adjustment of the infrastructure and the limits for the road carriageways. So let's try the planning conditions using the planning road methods. Now I can select and plan with some of the default information I have here for different country regions. And at the same time, I can use the default selections that has been indicated. Another way, I'll still definitely going to adjust the corridor or the sections to reflect what we actually need to provide for this road. So let's start. Major road is a 25-meter road corridor that also have drainage infrastructure and some other corridor build-up. So already this condition has been defined in my pellets. Now the pellets under the create option, manage options, you have under the content, we have what we call the style pellets. Style pellets give you all the details conditions for you to build up all your 3D models, your railway connections, your infrastructural utilities, water line, air interest components, as well as grading system, which are defined with the specific information needed or attached to those build-up. So, but in this case, we are using the road details to specify that. So under the road, we have the corridor details as specified. Accordingly, we've defined for the other design that we've carried out, we define the range for what we need to see in the as-built model, which has all the detailed information that was needed in order to carry out our design criteria. So we have 25-meter road extensions or right-of-way, and this we have 20-meter road right-of-way, and we have 15-meter access street road. So in this case, I'm going to use 25-meter road right-of-way and the 15 access for the street road. So in this case, we can check the conditions of this road by double-clicking on the created define to see what information build up that we have taken care of. So in the default settings, I created this road and I specify all the design criteria with the tracking settings, which show me the median as the green space with the curves which are defined to what I will get in our country conditions. Now, the median is the green area. Then under the medians, I specify the curves with their track width and also the offset height details, and also the type of information I need to showcase. Under the roadway, I've defined this roadway as this because we have two dual carriageway for the corridor or the large road extent. So all these definitions for the drainage line, which is shown as emergency line, in some conditions it has to be an underground channel which has to be coordinated with the corridor as well. But in this case, it was shown in the red dotted line, so that the line will define how my underground services will look like. And if it's an open channel that is needed by the client, it also specifies the range and extension of that line. And at the same time, all other things that we are seeing here, you're seeing the corridor, the verges, and the line you are seeing whereby for tree planting and other things has been defined. So this is how the information is built up and giving us the XY location positions, the elevation, which when we convert to component road will display such information. So now at this stage, we'll just have the setting base defined, which is shown here. Let me close it. Now let's look at this. As I said, I have to remove the overlay. At this stage, it's not needed. So having successfully do the planning of the road network from the site layout that was imported as overlay, which has been deleted. Then the next thing for me is to now convert this planning road into a component road, whereby I will specify the limit range for the road carriageway and the site for the drainage system. So in this case, now what I would do is this, as I said, as looking at the information we have, is that the planning conditions based on the parameter being set for the corridor extent, which the red line you are seeing is the where we have the underground drainage network for stormwater, whether it's closed circuit or we're not going to have open channels if dependent on the client's requirement. But the best suggestions in this workspace is that you can only have access to use the stormwater for underground piping system. So in order to convert this to a design component, you select that component, right click on it and convert to component road, which give us the standard for us to use our design criteria based on our country specifications. So from what I have, I've turned it to a design component. So at this level, I can observe the condition of my chainage intervals as well as the curve details and change the parameters. In order to see the profile conditions of this created road, I'll right click on that road and click on show stations in profile view. So from the profile view, something I can always work in Civil 3D, I can see the condition of my details. And at the same time, I can show what is the design speed has been specified. These are the conditions for this estate that was specified, is in line with the criteria that were defined, as well as these are the details I can show. If there are cases where there is elevation, you can show it as well. Then at the same time, you can insert other road components, place some decoration if needed, then adjust your design speed and also do a direct coordination with your stormwater drainage. But in this case, our reference line is defined as the alignment. So when I click on these design conditions, I can visualize it in the profile details of that road network. So let's look at this. Click on it. When you can see when you click on it, you can see all the chainage intervals. The point of curve details or the point of intersection details are shown with respect to the design criteria as being specified. So when I click on it, let's show the profile view. Now what I'm seeing here is the profile view of the locations. You can see. So at this level, I can do my adjustment with respect to details that reflect either my K value descriptions pertaining to this road. So these are the levels where all design criteria will be considered for the vertical profiling. Kindly note that design speed determines all other conditions that will define the horizontal profile and the vertical extent. So at this level, you can adjust, apply, edit, and consider the design criteria being shown for this road by adjusting all these details to reflect what you actually want. Kindly note also that this comes with an overlaying existing condition because we are visualizing not only the design parameter, you must also see the existing conditions underlying these design informations. So as well, other details for this can also be converted to a component rule. And now all this workflow has actually been turned into row conditions. So now, in order for me to now balance to do the exact details of what was positioned here, then I can decide to export this to Civil 3D. Now, what I will do now is to share and send these informations and export it as IMX. And you have to be very careful. You can determine the region of export, which I will define here. So as a polygon, I'll use entire model. I'm not using the entire model, but I'm taking this region of export, that is from the region of our coordination here. Take it, that is what I'm taking to Civil 3D, by exporting to Civil 3D as an IMX file. So if I'm taking this, now you have to very consider your target coordinate system. Remember, it depends on your country locations that you have to specify your system. And in this case, we are using HME 8432 as our export means of coordinating with our Civil 3D, which is also being set with a coordinate system. This is very important for us to adjust. So this is the project data that I'm sending to Civil 3D as an IMX file. So I'll send these details. After exporting our work to IMX, then we'll go back to Civil 3D to now coordinate the planning road corridor from InfraWorks and Civil 3D. So here in Civil 3D, we are going to coordinate the informations to move from the planning stage to the design stage. So it's very important when you're applying very critical design informations, you need to use 3D, which is also a BIM tool that will bring back the information from the planning stage into detailed design procedure with respect to their exact corridor. So let's check out information that we imported. So to do that, under 3D, we consider the InfraWorks option that we've used in the InfraWorks. So when I load it, I click on import the IMX. I'll open the file with the data that I save it. I'll open it. Now, when you open it, it will load the surfaces from the InfraWorks, because what we're seeing here in Civil 3D alone is only the overlay layout that will take to InfraWorks, and also the GeoT file for both map locations. So that's what we are seeing in Civil 3D. But by the time we bring out the IMX file, which will give us a surface of the digital terrain model of the map into Civil 3D. Now it has been loaded, but there are issues. Now these issues comes off from the condition of those alignment that does not fall in line. So let's quickly do a check view of the our existing ground details and bring them to surface, because all the coordinations were hiding in this interface. So let's on the box for the things that we have to see, so we can actually see them for all details as proposed. Check so everything is shown. So now reflecting on these coordinations, we're going to resolve the effect of this on our alignment. Let's check it out under the alignment settings to observe what is so we've resolved that. So now in all the information that we loaded, you can see from InfraWorks, the major road is indicated, you can see as well. Then the surface is also brought in as well. Because of the GeoT underlay, we can't see much of the information, but it's there. So I just want to leave the GeoT map to be displayed. So now it only shows those ones that form with the accuracy with respect to the line. You can see the straight line, they're accurate. Why the other one did not show? That means it was not reflecting on the actual reference overlay. So now we have this 5 has been defined. So now from the information we bring from the InfraWorks, we can reflect on the detailed differences of each of these roads. Kindly note, after importing the IMX file, now I will need to confirm our road coordination detail for the alignment, because other information was added to it as well. So you can see this is the already finished work, but this is the focal point of our discussions in order to build up. So the information has already been built up. So we can see the channel reference line can be stated. So we can need to confirm this shown road corridor as brought out from InfraWorks. So from the coordinations, I can check the numbering. It's given a default number. They can select the alignment. You can see this is the further one. So that means all these 4 reflect on the, so they are the number we are dealing with in that order. So from here now, what we need to do now, since I know that 192 represents the 25-meter road corridor, the name of the first alignment, which is stated as 192, I can decide to rename it and change the naming system if I desire to do that. So let's check the details. Select it, you can see this is the one. So I know that this is 192. So for the 192, I need to check the profile details, create surface profile for it, scroll down to where you have the 192 descriptions, and under that, these are the established informations that was built up, the information in it. So I draw in profile view. So I can just create the profile for that. So under the results, so I can see the coordination has been shown here, displaying that detail. So all I need is to coordinate that 992 details for the proposed conditions and the layout. So I can adjust this detail to reflect that. Under these conditions, I can reapply some of the information display that I have to see here. You can see everything is automated. All the informations for the geometric analysis and design has been clearly stated. Then at the same time, I can reflect on the profile as well to showcase only the details I need, which is the proposed ground surface. All these other ones, I don't need it, and I need the alignment for the 192 corridor right of way. So I can click on that, I've adjusted. You can see this is the coordination directly from the component design route. So I can check whether this is in line with the design criteria as stated for one of these roads. So I'll click on it and go to edit labels and import all the information on this as a complete label set. Then with that, I get all the information I need. Next thing I have to do is I can cross-check the corridor for this build-up. Now, under the corridor statement for 192, which we work on now, you can check what is the corridor that comes with the information from the BIM procedure. Now, you can now zoom to it to see it within the corridor. So what the assembly that reflects on that corridor. Let's check it out. 192 properties. Under the parameters, you can see we have this district collector road assembly. This one was defined. So let's check the assembly details that was created for it. So district, they have to be very precise. The assembly type, the name type has to be shown. This is not created here, but is from the building information model from the InfraWorks. From that coordination of the style palette, that's how I'm getting the description. So for me to understand which assembly is refined for the 192 descriptions, I can check the properties and check what is it. District Collector Road Assembly 28 as stated. So I have to go to the assembly of that District Collector Road 28 as stated to now check out my information. I can bring this as well, expand it. So this is the information at 28. Then I can zoom to it. Then after zooming it, I've seen the corridor descriptions as stated in line with what it comes from the InfraWorks. So this is one of the showcasing of how the building information detail the geometric design of the road infrastructure. But in this case, we've seen the right of way as described from InfraWorks. It may not define the slope pattern and the drainage corridor. So in that case, I can decide to modify this condition of the assembly as defined to now define precisely where I want to locate my storm water drainage system. Now, what is the coordinations I use for this? The references is showing 12.5. It has to be 12.5. So what I will do now is under the references, I can actually decide to check the 25-meter road parameter descriptions, select for the review, zone to that side. Now, this was our expectations from the coordinations, how it will look like. It now tells me that because of the requirements of that extra locations, they want an open channel with these conditions as defined for what their section will look like. So I have to change this parameter to reflect these conditions. Let me remove this. I don't know where this one is assigned to. but I think it will go from here. I'm just moving, sorry for that. So now it's reflecting that this will reflect these their own descriptions. And I have a coordination from infra of my builder, so I can reflect that changes from here. It means that 195 units, I can change descriptions because with the information that's being given now, though it's almost in line with that, but because of the condition of the requirement for the drainage has to be in this line, and the slope pattern has to define how it drains to this, and also what the build-up has to look like. We're supposed to give me 3.5 entities along that line for each side, which make 25. But the coordinations in 28 in extend descriptions from our control zone to give us that it ends at 12.20. So I have to balance it and ensure that it drains to the inlet of a closed network of drainage system or an open channel. So now it means what I will do is from the corridor for 192, I can only just need to change that to reflect that changes. The information are there, so you don't have to bother. All the information needed is completely there. All what you just have to do is just change it to the new information that the client requires. So all I have to do, this is the information the client requires, zone to this information. So what I will do is just go back to the corridor details of 192 and select the properties, the information needed. I will just update that information to reflect that conditions of 25 days as stated, and by default, the information corridor will be built and give the conditions as defined by the client. So these are this. So I've updated it as well for this one route. Because of time, I just use this single one to explain. I'll not be able to go through all the 5 roads that will determine. But for this one, the property, I can zoom to the corridor to check the details presentation. You can see. So this is the update and the base map, so we can see it clearly. This base map, let me just uncheck it. So I'll check it back. So I want us to see clearly. So now it is the extent of the coordinations that I've seen. So they are defined for me detailed. Now I'm seeing the what we call the daylight condition, how it expanded into the other surfaces. The coordination is showing in line for the changes. You can see now the control is showing the stormwater line, the drainage line, which the color code showing the flow line of the drainage based on the latest requirement. So this is now updated to reflect the new changes as observed. The information is well precise, accurate. So in order that I'm able to balance these conditions, I can now observe that the report, the information I needed is already in what we call a spreadsheet, whereby it can be processed and exported as a single format for detailed information to be established. So what are the reporting formats? Let's check that out. Because of time, I'll not be able to get to other controls, but I've used this to explain how everything can be made easy from the control of creating our drainage and stormwater infrastructure. Now, with the updated version now, I cannot decide that the stormwater line for the inverse level with respect to the extension of the line should be defined in the profile as well. So in that case, if it's an open channel, I can now create what we call profile, create corridor from profile to reflect the corridor flow line. So this is the flow line, this color code I selected. When I selected it, I can now stage drainage invert level for the workflow. So, and I can give any types of style. So it doesn't matter. So when I click on that, so this drainage line for the connected stormwater will now be defined in my profile. You can see it's in green color. Now for the top crown level, I need to create a corridor surface and stated that I want to observe the count finished ground of this information. So I'll clear the corridor surface. So this one can give me the computation for my cut and fill volume and for my artworks analysis. So in this case, sample line can be defined for this 192 corridor. Let's check it out. And the sample line as defined is to show me some extent of the work that I'm doing, which have to reflect for 192 corridor is being selected with the existing ground condition is being selected, and also to reflect the proposed ground conditions, which is also selected. This one is not needed. So I selected this, then I selected these three items, which are the most versatile information that I need. And I can say this sample line collection for 192 right of way. So when I define that, then the range of station that I specify has to be defined. That is, for me to observe the road right of way, which is for each side is 12.5, making 25-meter right of way. But I can use that to coordinate what is happening from the right of way into the plot of land. So I can now say the extension for each side, instead of it to be 12.5, now to extend into some land areas, I can specify, let it be 20, so that I can observe what is happening within the other locations of the site. The right side to be also be 20. Kindly note, our increment relative that we decide here for the alignment change interval is 20. So your tangent coordination for the increment in curves and in spiral must also be 20. So these are information that already be input. I'm just doing some review for the design based on the information that developed from InfraWorks to now reflect those changes to meet up with the design criteria expected. So from this, I've coordinated that. So I've created a sample line, which I create an offset to enter some of the land plots to understudy if perhaps a plot of land can be here for either residential or commercial entity. So I can now edit these details of the sections, and I click these sample lines. I'm just going a little bit fast just to explain with this case study as an overview of what we've done in some of the projects that we've carried out. So in this case, I don't need this. I need to extract the section mark to define my cutting of the sections at interval so that it can display for me all the criteria, all the things that I needed to coordinate for this workflow. So now from the course sections I observe, I can now check out the information for this. I've defined that, so it has been clearly stated. So now I have the sections cut at 20 meters interval along that corridor as defined. You can see the information is already there. So from that corridor, I can now select this to define what I want. Alignment under 192, under the alignment, under the sample line group, sample line collections, properties, then I can have the proposed ground and the 195, so I can import those criteria to now define whether the actuals or the cut time. So let's see what we have for the existing ground, which is the proposed ground, and the datum is the 192 profile. So I can apply that. This has been defined. Okay. So under the toolbox, let me just consider the corridor information. Now I need to consider this corridors, what we call the slope stake report. You can see I have material list, but the selections that I want to work on is on for the selection for the crown levels as stated. So you can add that to the material list. So this to show me the crown level coordinations with respect to the corridor. So with this, I can now drop the report information is already there. So what you can adjust is to check all the report informations, whether in Microsoft Word, in Excel, or in PDF. So has already been structured. So let me check if it's in Excel. Let's look at what we have and the civil report for 192 is just the descriptions. So let's just assume that and create a report for it. Let's see what we have. Yes, the report is being created. So all entities about information that will assist us to have a well-coordinated road network and storm drainage facilities. So the report is being created. So now the report for the corridors checkout has been created for 194 right. We can see this is the Excel program, completely information at each unit interval. At its 20 meters interval of change, the information has been shown in line with what we expect to see for the ground level for a corridor build up, including where we have the stormwater drainage has been showing for the China right of way, both top, the sidewalk, and all details is reflecting in the descriptions as stated. So this is clearly and very good indications of what is happening for huge coordinator site. So this can be given, you can see the extension for the right of way into the plot of land defined. So this allows whether the surveyors or the geoinformatic professionals to now get this information in Excel and cross-check the feasibility of position residential building as some lanes of land, some corridor right of way or far away from it. So these are one of the information we can get. So a lot of information which is gotten for the BIM procedure is being imbibed in this process and workflow. And the coordination references, which is the foundation for all that vertical BIM procedure. So these are some of the things that are critical that define some information that have to be brought out in drawings. These are some details, procedures, and processes that was carried out by us using the BIM process. And you can see the information are detailed and well defined to reflect what we actually want and to bring out what we actually need to see. And these are the things that comes from infraworks integration with Civil 3D. And this give us the position we use to coordinate with the construction professionals. So these are some overview of the breakpoints of information that were detailed, showing information that are critical, showing the analysis pattern, and which have been broadly breaking down into this. For instance, what you are seeing here is a complete roundabout design carried out for the procedure where all sections are being cut. This is the coordination that was also done in infraworks and showing the element of design for this roundabout, which was shown here as well. So these are some of the things and the benefits of working with BIM for infrastructural planning of road and stormwater drainage. If you go back to the infraworks, now that builder that I show for the roundabout is clearly stated here as the final entity that we build up with information we expect to see. This is the roundabout coordination shown in the opaque color, and you can see the stormwater coordination by the side and showing the line and the trees and the details. This one we've not coordinated showing the trees. You can see all of the information are showing on this corridor. So at this point, I think I've done justice to explain a case study in our ongoing workflow to explain to us how we can maximize the use of building information modeling in our infrastructural planning. A quick overview of the cases that I've shown to you result into application of this in Africa, especially in Nigeria. I really appreciate all of you that listens to these sections, and I hope in due time or in the nearest future we start to apply the BIM procedure in all our design and construction workflow. Thank you all for watching.